Good morning, everyone. Welcome to Lighting Retrofits and Audits. We are having some really fun technical difficulties this morning, but Eric's getting it figured out. Until we get going, let's just hang out. We are going to do something a little bit different than we normally have today. I should say, I'm Katie. I work for the Lighting Design Lab at City Light. You are in the right place if you're here for lighting retrofits and audits with the wonderful Eric Strandberg, who's I'm sure you all have seen and heard many times. We are going to use Slido today for polling. If you've never used it before, you can do it through your phone. There'll be a little QR code to scan, or you can go to slido.com. And as soon as we get the presentation up and running, there will be a little like entry code that you enter to get into our polls. That won't happen for a little while. How's it going, Eric?
We're very close.
Excellent. Computers crashing on the day of a webinar is, I don't know, maybe it's good luck, Eric, like when a bird poops on you.
That's possible.
Maybe. Maybe it's good luck for the Seahawks tonight.
Oh God. Anything.
Well, while we don't really need the slides up for me to tell everybody sort of the housekeeping stuff. If you haven't had a class with us before, everybody's on mute in this platform, but there should be a little questions box in your menu bar that you can type in questions at any time, and we will get those answered. If you can't find the menu bar, GoToWebinar is kind of interesting. It collapses that menu bar once in a while, so there'll be a little red flashing arrow maybe, and if you click on that, it should expand the menu back open. We're recording this, so everything that's going on right now is recorded for posterity. Yes, we might clip this part out. Oh, Eric, looks like it's going.
Something's going. Let's see. Not
Something's
quite the
going.
one. That's the one we want, I think.
And so we put the recording up on our website within about a week, or sometimes a little bit longer, from the classes ending. If we have a slide deck available, we put that up too, so you'll have that to download and make notes on. Let's see what else. At the end of the webinar, there will be a quick little, not poll, survey. Give us ideas for other classes you want to see. Rate this class. Please be kind that we had technical difficulties. And oh, I saw the presentation for a minute.
Oh, it went away?
Now I see it again.
Okay.
Can you advance? Does it work?
Let's find out.
Behind the scenes stuff, guys. Yep. Okay, I got all that stuff. That's what the questions bar looks like. Maybe click the next one.
Yeah.
If you're impressed with how we're doing right now, come back on December 7th. We're going to have an overview of the CPACER program. It's a financing program that not many people actually know about, I think. You can use it for new construction and retrofit. All of these new things that are, code implementations and electrification requirements cost a lot of money. So knowing all of your financing options is important. And then in January, we're going to have a class on manual J and manual S, which is super important when you're sizing heat pumps for residential applications in this instance. And I think that's the last slide I have right now, Eric.
Yeah, let's see.
Remember. Does it go to you now?
I
We
think
usually
There we
do
go.
this foolishness before you guys get on. There we are. Okay, so I'm gonna hand it over to Eric, and he'll teach you guys some good stuff. Thank you, everyone.
Yes. All right. Well, thank you all, and sorry for the hiccups there. We had, it's always something. So right, audits and retrofits. I love this slide because it kind of keeps me humble. A lot of times I think everyone's world revolves around lighting, and this is a good reminder. This is a picture I took at a little restaurant, sort of a cafe, and clearly their value was getting that radio working, and they unplugged the light and plugged their radio into that little light socket. So, you don't always want to assume that everybody is as eager about lighting as you are. That's to know. Right, I'm Eric Strandberg, and I've been at the Lighting Design Lab for a long time, and been working on all things lighting, writing articles, teaching classes, doing client visits, site visits, consultations, you name it. So if you have any questions about lighting, my knowledge is a mile wide and about an inch deep in some places, but give me a call or send me an email, and I'd be happy to see what I can tell you about your questions in the future. So what we're going to do today is just talk about a little overview of the procedures and issues around doing a lighting audit, look at some common retrofit applications, and then we're going to talk a little bit about Luminaire Level Lighting Controls. I know you're all excited for that. And we're going to try one of our little Slidos here. So let's see how that goes. I think Katie's going to run the helm on that one.
You're not logged into it.
Oh,
so yeah,
I logged
unfortunately.
in.
Well, the login in PowerPoint isn't logged in, I think. So we might. Do you want to skip it?
We can skip it. Mostly I was just trying to get a sense of, the audience today. But I think what we'll do is just assume
just type in the chat.
Yeah, if you've got questions, we're more than happy to try and address those for you. And I can't really, I know I can sort of see the chat. Yeah, sorry about that. Let's just power through this then. We'll go to the next slide. If we can do it, here we go. All right, so when you're starting a project, meeting with the various players, it's always good to not really make assumptions about what you think the goals and motivations are for this project or for your client. A lot of people say, I want to save energy, and that's admirable. But what they're really interested in is saving money, and that's actually important too. Saving on operating costs is just good business sense, and so one way to do that is by saving energy. But if the primary goal is to save on dollars and to save money, that's going to send you down one path. If their primary goal is to save as much energy as possible, that's going to send you down maybe a slightly different path. I could walk into pretty much any building and save energy. It may cost a lot to do that, and it may ultimately not be cost effective, but there's ways to save energy if that's your primary goal. Perhaps your client wants to be LEED Platinum. They're going for LEED existing buildings. LEED is a way to measure and award energy saving projects. perhaps they just want to, they have bad lighting and they want to enhance the lighting quality. It's possible that the system is, aging out as an old system and they're going to replace the lighting anyway. And so at that point, it's sort of like, well, how can we do this most efficiently, save some energy, save some money? It could be any number of things. Ideally, on every project, you'd be saving dollars, you'd be improving the lighting, you might be meeting code. Obviously, you'd be meeting code if you had to. So don't assume when you walk in what the goals are. And another thing that's related but not completely is make sure that everyone's on the same page. What is the priority for the various players? Perhaps you've got an owner, their primary interest is long-term costs. You've got a tenant, and maybe they're interested in a green status. They want to tell their clients that they're working in a LEED silver building or something like that. The engineers, perhaps they're interested in maximizing energy efficiency. Contractor, maybe their concern is lowest first cost. Facility operator, they're wanting a low maintenance system that's going to be easy to operate. The users, they just want good lighting, and perhaps the architect is very concerned about the appearance. Ideally, everybody would get their needs met, and it's not impossible to hit all those buttons on a project. But it's always good to be aware of those things. So, you're called in, typically, when we get called in on a project, it's because there's problems. There's lots of easy projects out there, but there's also, difficult areas. And, you don't want to get bogged down right off the bat on the hardest part of the project. Pick the, take the big view, look at the overall project, find out if there's lots of easy energy savings, and then once you've got all those things lined up, then spend some time on those difficult areas. Another thing you might do is press a little bit if their goal is to say retrofit all the lighting. We hear this a lot, that we're like, well, we want to go all LED, lighting emitting diodes. That's the new light source, and there's a lot of good reasons to do that. But some fixtures are going to be very difficult, if not impossible, to really retrofit with LEDs. And so, you're looking at probable replacement of those fixtures, and you just want to find out if that's really within the scope of what they're willing to do. We've seen a project where, everything was pretty much easy, except they had some bollards out front in their parking area. And those were just going to be impossible to retrofit, and they were relatively new fixtures. So replacing them wasn't really a great idea. The other thing that you want to always ask is how they like the existing lighting. Do they like the lighting? If they like the lighting, then you want to make sure that when you do the retrofit, it's pretty much like it currently is, or perhaps improved if possible. If they don't like the lighting, then you want to make sure that you're not just replacing sort of one for one and giving them the same old crummy lighting that they had, except it's now all LED. So it's always good to press on that a little bit. One of the things you want to find out too, while you're doing this sort of preliminary survey, is this a good candidate for a retrofit? And there'll be some clues to determine that. Obviously you're wanting it to be cost effective if possible. And so you want to look at the hours of operation. Does the facility have long hours of operation, or are they short hours? If the lighting's on a lot, then it's going to have a big impact if you can do some energy efficiency measures. How old is the system? If it's an old lighting system, then there's a good chance that putting in new modern lighting is going to be a win. Does the utility have, demand charges, or just basically high energy rates? We've been in some areas of the Washington state where the energy prices are so low that it's going to be very difficult to get something with a reasonable payback. Although those days are, the rates are generally going up. Different things. Are there lots of incandescent lamps on site? Are the light levels very high? Like for instance, this space that we're looking at here, this looks like some kind of server room, maybe from the 80s or something like that. The very high light levels, probably very long hours of operation. So it wouldn't be hard to go in there and put in modern lighting that would save some money. You walk in there, and if you have a light meter, you can take a light reading, and it might be 120 foot candles, which is, say, a lot for an interior space. And I've seen that in offices before, and so you could cut that down by 30-40% even, and still have a very bright interior if that's important to them. The thing you want to look for is the opportunity for introducing some daylight, maybe not in a space like this, but always look for those opportunities, and also look to see if there's controls that you can put in. Maybe people come into this, say, server room a couple times a day, but take some readings, but for the most part, maybe they're not in there. So you want to find that out. Another thing that doesn't hurt is to see if you can find out how much the client is actually paying for the lighting. A lot of times they don't know. They just see a big electrical bill and they assume it has to do with all of these things. But if you can parse out what the lighting component is, that may open their eyes and get them to do something. If it's projects that are not particularly cost effective, would be ones that have fairly short hours of operation. Maybe it's just a sort of 9 to 5 operation, 5 days a week. And so they're not really using a lot of energy. Facility exceeds the existing efficiency requirements. Maybe it's already a fairly new building, and it's got relatively stringent energy code thresholds that it's already met. It may already be a green building, as they say. Maybe the facility's undergone a recent retrofit, so the building's old, but you can look at the lighting and say, well, this was retrofitted, 15 years ago. So it's still fairly modern lighting. All those things are going to be important to know going in, so you can set your client's expectations. So looking at a couple of examples here, we've got, if we look at the pictures on the upper right, we've got a big stadium. Those stadium lights are probably 1,000 watt, maybe 1,200 watts a piece. So you're thinking, wow, there's a lot of energy there when all 60 of those are on, or however many they've got. And then down below is a community center, and maybe those are only 150 watt metal halide lamps or something. So it doesn't seem like as much savings, but guess what? The stadium's only lit for maybe a few dozen times a year, whereas that community center, those lights are on 7 days a week, maybe 14 hours a day. So it gets a lot of use, and so the savings could be much more beneficial. Another example might be, we look at 2 lobbies down in the lower pictures. They look similar. One's an office building and the other is a hotel. Well, the office building, again, they may have, maybe they're open at 7 in the morning till maybe as late as 6 o'clock or so at night, and that 5 days a week. Whereas that hotel, that's 24/7 operation, every day. So those lights are constantly on. It's possible they have maybe a little nighttime turn back, but possibly not. So there's potentially quite a bit more savings there. And you'll see that too with other types of stores and big box retail. That may have 14 hours a day, 7 days a week, whereas a warehouse, maybe the warehouse is really only operational pretty much during business hours, 5 days a week. They're not running 2 shifts, and they don't do anything on the weekends. So you just have to look at those numbers there. You want to do a plan review, and that can be fairly cursory, or it can be very detailed. It just depends on what they have available. You might have a fairly large facility like a school where there's just lots of different rooms, but guess what? A lot of the rooms might be very similar. So once you've figured out what they have for their classroom, you're just replicating that over and over. You can look at what the local codes and standards are and see what the recommended light levels are based on either, maybe they've got a campus-wide standard that they use, or there could be recommendations from a governing authority like the Illuminating Engineering Society, the IS recommendations. They maybe say, well, we just follow that. And that'll just give you a sense of where they're coming from. We'll talk about that a little bit more as we go. So as you go out to, even doing a basic walkthrough, some things that you might want to have with you would be a light meter. For me, I don't put a lot of stock on, measured foot candles, but it does provide a reference for what's there, and it can give you at least something that you can come back to, and we'll talk about that a little bit more. You want to be able to measure things. One thing I can do in certain kinds of spaces is count ceiling tiles, and if the ceilings is a 2x2 ceiling tiles, or maybe 2x4 ceiling tiles, and you can just count them, and that's a way to get a rough measurement of the general size of the space. Laser pointers are good, or rather laser measures, but just be aware that those don't always work outside during the day. Just there's too much light to really see them. So be aware that if you're doing that, you may want to bring a 100-foot tape or something like that if you're doing exterior light audits, so you can figure out how far the poles are apart, the poles are, or something along those lines. Bringing a notebook or a tablet, tape recorder, but ideally with a transcript app, so you're not just having to write everything afterwards. A camera with a zoom and maybe even a wide angle. We'll talk about that in a minute. Binoculars or a little monocular isn't a bad idea to have for reading labels or just getting a sense of what's going on with some of the equipment. And then, of course, your usual earplugs, hard hat, goggles, etc., if need be, if you do, particularly for an industrial setting. A counter, so you can count lights as you go and not forget. And then if you're doing, if the client's interested in a rebates, bringing the forms, particularly the utility forms, can be helpful, so you can make sure that you're getting all the information you need there. So when you are looking at the lighting systems, you're going to want to look at, as I say, the existing light levels, especially if the client says something like, oh, it's not bright enough, or they say it's too bright. That can give you a reference point. You want to look at the types of luminaires or light fixtures that they have in place, and look at the mounting, how they're mounted. And just one little note, sometimes you can have a facility that has the same or similar fixtures mounted just in different ways. A lot of times we'll see a particularly industrial or commercial, some utility applications where they've got like a wraparound type fixture, and they've got it hanging from chain, they've got it mounted to the wall, and sometimes the same fixtures is stuck to the ceiling. And so that can be an easy way to know that even though there's lots of fixtures, they're all pretty much the same, if not identical. You want to look at what lamp types are in the fixtures, and look at the color, to at least take a note of the color of the light. If the color is consistent, if you can find out the wattage, that's always helpful. You'll definitely need to know that at some point. And the ballast type that they have, particularly for fluorescent systems, what kind of daylighting conditions they have, and is there an opportunity to improve that? Have the luminaires already been retrofitted? So you're looking at all of these fixtures, but you want to open a couple and just take a look. We'll talk about that, and see what kind of lighting controls they have in place. Do they have any occupancy sensors? Are there photocells? That sort of thing. And then check the room reflectances, and we'll touch on that a little bit later as we go.
Hey, Eric.
Yeah.
Erin is wondering if you have any specific models of photometers or any of the other field equipment that you recommend, or anything along that line.
Yeah, it kind of it depends. The ones that we've used at the lab are sort of industry standard testing lab style meters that are made by Konica Minolta. They tend to be fairly pricey though. They're going to be $1,000 or so a piece. And honestly, for most applications, you don't need that level of accuracy. I've seen plenty of meters that are under $100. Those can kind of work, but it's like the old joke. If you've got one clock, you always know what time it is. If you have two clocks, you're never sure, because some of those less expensive meters are going to be reading differently. And so if you're out there taking measurements and then someone else comes out and has a different meter, they're going to get different numbers. And if your meter's, isn't very good, it may not show well for you. I've seen meters that are around the $250, $300 that are going to be fairly good, and it just depends on what you're using them for. If you're really trying to meet stringent standards, maybe classrooms where you have to have X number of foot candles average in the space, and you want to be able to show that that's actually what you've got, you're going to want something with a reasonable degree of accuracy.
And I would put in a plug for the tool lending library at the Smart Building Center. If you haven't had experience, because they've got hundreds of different little gadgets you can check out and play with and see how they work for you before you go and invest, if you do think you might have to go the $1,000 route. And then as a follow-up, Erin was wondering about phones and apps for this kind of work. Is an iPhone good enough, was the question, and if you have any apps that you like.
Yeah, I've got a little light meter app on my phone, and I just would say that, that's the kind of thing where if you walk into a space and you want to find out, because it's often hard to tell, light perception of light varies greatly. Like you could be out on a sunny beach or a ski slope, and there are hundreds, thousands of foot candles out there. It's so bright, you wouldn't believe it. And your eye perceives that once you're used to it. It just is what it is. You don't even need sunglasses, although you might want them. You could also be in a interior corridor that's got maybe tens of foot candles, if that. It might be 20, 25 foot candles, and it'll be plenty for what you're doing, and your eye adjusts to that and it seems normal. So your eyes are not the best tool for judging how much light is in a space. So having a meter tells you, okay, have we got 15 foot candles, or is it more like 65? And a phone app might help you with that. But if someone's saying, hey, we need in our warehouse aisles, we need 40 foot candles vertical on these boxes, taking out your phone out probably isn't going to be the best way to instill confidence. So that would just be the only thing I would say about that. It might be fun if you're doing a preliminary survey, you could say, wow, you're only getting 15 foot candles here on these warehouse boxes, whereas you really need, probably 3 times that much. It would be something. So it doesn't hurt, but it's not great. It just gives you sort of an order of magnitude. Hopefully that's helpful. The only other thing I guess I would say about these $1,000 meters is they have the ability to be calibrated. So you buy the thing and then you can set it off. In theory, you'd set it off every year to be recalibrated. And that can be a fairly expensive process. It just depends on how much authority you need to have in terms of saying, this is how much light you've got, regardless of what someone else says. So what is the condition of the existing lighting? Okay, so you've gone out there and you've looked at the space in general, you've looked at the luminaire types, but what condition are they in? And generally, what's the building conditions? What's the ceiling type? Can I access the spaces that I need to, plenums and such? Are the controls being used? Again, coming back to daylight opportunities. And here with this warehouse, we see it's got the potential for daylight, but they've all been covered over with dark green material. So you could potentially get some good daylight in there. The reflectance of the interior surfaces, we'll talk about that. And it doesn't hurt to find out where their maintenance closet is. And you can take a look in there and see if they have any spare light bulbs that they would be using. That'll give you a sense of what they've got. Maybe it's a whole hodgepodge of things and you just know, okay, this is going to be very little consistency here. Maybe they have some spare luminaires. So we have a little quiz. Katie, I don't know. I think what I'm going to do is just talk through these as we go. What do you think? Yeah, because I think our Slido isn't working. And so here, this would be a little review, we'll call it. Which of the following suggests that a retrofit is likely to be cost effective? And as we talked about, the facility has long hours of operation, so check. Measured light levels are higher than recommended practice. So yeah, that's another positive. So here we've got a community theater that has 50 stage lights that are 500 watts apiece. And so here's a case where we've got high wattage lights, but they get very little use. Maybe they do 4 productions a year for 2 weeks each. So otherwise they're off. So not probably a lot of return on an annual basis there. Hospital parking garage with 30-year-old lights. So, again, a parking garage is going to get lots of use, particularly at a hospital. It's 24/7, and the lights are old. And then the customer is going for LEED existing building certification. So all of these really, except that middle one, would be good opportunities. All right. So documenting existing light levels. So we'll probe on this a little bit more. So what is being proposed? A lot of times they'll say, oh, well, we need 100-foot candles, and I've seen retailers say that. That's just what we need. And it's a nice high round number, but what's it based on? You can find out, you can ask them about that, and we'll touch on that in a second. What is recommended, and then what is that based on? They might say, oh, well, we've heard we need 70-foot candles. It's like, okay, who told you that? Are the light levels consistent throughout the space? And sometimes they're like, oh, we just need more light in this warehouse, and it turns out there's a couple of aisles that are dark because maybe some fixtures aren't burning. But for the most part, if they had all the lamps, if everything was lamped up properly, the light levels might be pretty good. And then are the users happy with the light levels? They might say, oh, it's fine, but you walk in there and you're like, there's a safety issue here. It's just we need more light. Or they might say that they don't like it. But again, you're thinking, well, it's not that bad. So then you have to find, well, what is it about it that they're not liking? And so it doesn't hurt to have some of those conversations. So as far as documenting the existing luminaires, it doesn't hurt. Everyone's got an iPhone. You walk into the space, you can take pictures, you can even get a close-up. And that's pretty good. But I'm recommending that you use an actual camera that has a zoom lens, and it doesn't have to be a fancy camera. So here's an exercise I went through. So here's a light that we wanted to take a picture of, and we wanted to find out more about it. It's up in the air 17 feet. So we could get a ladder out and try to get up there if we even could really do that. But usually that's not practical, especially on a simple walkthrough. So I zoom in on it with my phone, and I can get a picture. Here, let's see if I can get my little pointer going. Let's see, we'll do a laser pointer. So here I've got I zoom in, I see a label there, and I can take a picture of that. But when I get back to the office and put it on my laptop or whatever, and I zoom in, I really don't have any, it's just garbage. I can't really read that. Whereas if I had an actual camera, and again, this is just a little 12x zoom in pocket camera, I get back to the office, I can follow all kinds of things. I can tell who makes it. I can tell the model number. I can see things about the wattage, maybe some date information, voltage, etc. So just a lot that you can get if you have a better piece of equipment. Here's another case where I did, this is a canopy light over a parking area, exterior parking. And we were wondering, we're going to retrofit these fixtures, metal halides, and the client was pretty sure they were 100 watt. But we took a picture of the label, zoomed in, and it turns out 70 watt. If we just gone on the basis that, okay, 100 watt, we're taking notes, we go back, we run our calculations on basic potential energy savings, or we do a lot of work based on that, and then we have to redo it all, plus the client's expectations, maybe the incentive would be considerably less based on that. So it does, and getting a ladder out or a lift out to read that on site just would not have been practical. So it's good to have that equipment. Another thing that you want to be aware of, and this sounds like a fine point, but it's really not, is how is the light being distributed out of the existing luminaires, right? So here's a high bay type fixture. It's got a metal reflector, so all the light is going to come straight out of the bottom of that fixture. Same thing with this shoebox style parking lot light, a recessed can, all that light comes straight out. Here's a cross section of a fluorescent troffer, direct light, all that light comes straight out. Same thing with these cylinders. So we call that direct luminaire. Or is the lighting indirect, right? So we've got a dish type fixture, maybe it's a metal lens or even a translucent. Sometimes it can be glowing a little bit, but it's really only sending about 5 or maybe as much as 10% light out. Most of it's just bouncing up and off the ceiling. Here's a linear pendant, indirect light mostly, a little bit comes out the bottom. Again, we have a cross section of indirect, all that light comes up and out, wall mounted, coming out, bouncing off of an adjacent wall and seals. See here. Good to know that. And then some fixtures are going to be, a lot of fixtures are going to be some combination thereof. Some light goes up, some light comes down. There's a wall-mounted fixture. We got a dish. Maybe this one's a better performer, so it's sending maybe 30% of the light out there. We're still getting indirect and a direct component, linear product. A good amount is out the bottom. And even some of these prism type fixtures, if they're, depending on how well designed they are, if it's an actual glass prism, most of that light will be coming out the bottom, even though it'll glow a little bit at the top, and that's by design. Whereas others, maybe it's molded plastic, it's sending light out the sides and out the bottom. So you kind of need to know a little bit of that information. One reason you need to know that is, let's say here's your project and the client has these schoolhouse type fixtures, and these are just sending out uniform light pretty much all directions. And there's, you know, they want to retrofit them to something maybe more modern or whatever, or somebody, their brother-in-law had this fixture that they could get inexpensively. So they're going to take out those and put in these, and this is a metal cylinder. You just need to know, and you need to let them know, if they don't already, that, you know, the light's going to come mostly down, just a little pool on the table. That's exactly what they want. But it might be a big surprise once you get everything all retrofitted and it turns out the ceiling's dark, the walls are mostly dark, and just because they didn't really understand what was happening. So then, you know, as far as auditing, you know, looking at the overall condition of the components, you've had a chance to look at the general outside of the fixture, and maybe you can tell a lot just from that, but sometimes you can't. So you want to open up a few that you think are representative. You know, are the sockets all worn? Do we have stuff dripping? What is that? Is that water intrusion? Is it some sort of fluid coming out of some of the components? You know, what's the deal? Is the wiring all haywire? Has it been retrofitted? That kind of thing. You know, a little superficial dust isn't what you're after, but it's, you know, basic breakdown of the components. And maybe they're like, well, we want to retrofit these. You're like, you know what? By the time we replace the sockets, the new lens, new you know, put in LED, you might as well have put in a new fixture. So that's always good to find out. So if you are replacing fluorescent lighting with the LEDs, and we'll talk about that at some length later on, you're going to need to look at the ballast, and that'll tell you a couple of things. One thing, it'll tell you the voltage. Like, do you have 77 volts or do you have 120 volts? 120 volt. How old is it? Because, and we don't see this as much anymore, but if it doesn't say no PCBs on it, you have to treat that ballast as though it's hazardous waste, and it requires a special handling. It'll say no PCBs on it, a little hard to read here, but if you look, and then you can just dispose of it, you know, like you would any other piece of waste industrial equipment. So, you know, a lot of times the utility, especially if you're wanting a rebate, they'll want to see the ballasts. So you don't want to just throw them all in the dumpster before you've had a chance for an inspection. Another reason you want to look inside is sort of twofold. One is to see if they're consistent, right? So this is in one room in one building, and we found, and we don't need to get into all the details about this, but we found a 2-lamp normal ballast factor, a 2-lamp low ballast factor, a 3-lamp normal ballast factor, and a 2-lamp fixture. We found some battery backups. We found some 277 volt product. So it's some retrofits that you do, the idea is that you're going to use the existing ballasts, and we'll talk about that later. But they have to be consistent. They have to be adaptable. And if they're not, you're going to run into problems. And so here we have a whole hodgepodge of things. And so you have to do that going in. It's pretty rare that you're going to find all the ballasts all the same. So just keep that in mind. And then you want to look at the existing controls. You know, especially sometimes you're in a situation where certain controls are not allowed. For instance, you know, an older way that we would see industrial applications, or sometimes even like in a school gymnasium, they just have breakers that control the lighting. And so someone would come in at 6 in the morning and flip all the breakers and all the lights come on, and that's how they would do it. And that's not allowed anymore. but they may have old mechanical time clocks. Those aren't allowed. It may be sensors, particularly when you have exterior photo sensors. They really take beating. So you just want to be prepared to replace all of those on any kind of retrofit. Or they may have old style dimmers that won't be consistent with the new lighting or compatible. I also want to look for a chance for some easy wins. So here's a case where we have a canopy with lights that are on all day. These could just be on a timer. You could say, okay, at 9 o'clock in the morning, we're just going to turn these off every day, and they won't come back on again until 5 at night or something, or even 6. That would just be so simple. If you could put sensors in there, obviously, that would tell you when it's not daylight, and that would be another easy way to do it. So while you're out there, you want to look at the room surfaces. What you're trying to do is improve vision when you do a lighting retrofit. You're at least trying to help the lighting help people see. And part of that system is the room surfaces. And they can, mitigate brightness ratios, we'll talk about, which is controlling contrast of tasks and backgrounds. And they can also just get more light from that. So here's a case where I just did a little model of a simple 2-story little office building, we'll call it. We got some windows, but let's say it's nighttime or early morning. And we've got a first floor and a second floor. And the second floor looks brighter. And there's a reason it looks brighter. That's because it actually is brighter. And we can prove that if we go. So took light level readings or at least modeled the different light levels. And so, depending on your skill level or maybe the team that you're working with, it may be that you're going to run a model on some of these spaces, particularly warehouses or simple big box type spaces. Even parking lots are fairly easy to model. And that's just a way to double check. But if you're especially some simple models, modeling platforms, all you do is put in the number of lights you're planning to use, generally the geometry of the space, and the layout of the lights, and then you hit the big go button, and you'll get a number. And it's like, wow, 35 foot candles, let's say. So here's our average foot candles. We get 35. We'll use that as our baseline. If you don't, usually the default reflectances are 70% reflective for the ceiling, 50% reflective for the walls, and 20% reflective for the floor. That's usually what comes loaded into the software. And if you don't change that, that's the number you'll get. But let's say your client or the project, maybe they've got a wooden ceiling, it's decking or something. Or maybe they're planning to remove all the ceiling tiles and spray the ceiling out, dark gray or even black. Obviously, the ceiling reflectance is not going to be 70%. Maybe the walls, maybe they've got brick walls, or they've got wood paneling that they really like, or who knows, maybe it's just tilt up concrete, raw concrete. So you're not going to have 50% reflectance, it's going to be a lower number. And then the floor might just be stained concrete, or maybe just even dark carpeting or tile. And so instead of 35 foot candles, you're only going to get 23 foot candles for the same light fixtures, same lighting layout. And that'll be a big surprise when you flip the switch and the client walks in and says, what happened? Hard to change that. Plus you look at contrast ratios. Here we're about 10 to 1, brightest to the darkest spot in the room. Now we're 21 to 1, 20 to 1. That's, that might be fine for certain types of restaurants or nightclubs, but not particularly in a place of business. Now, if you did high reflectance materials, a high performance ceiling tile, maybe a lighter colored wall. Again, we've just got light colored wall here. These are both off lights, It's just this one has higher reflectance. And maybe in this case, the floor is like a bamboo wood, so it's brighter. We go from, instead of 35, we got 52 or 51 foot candles. So you say, well, we don't need that much light. But what this says is this gives you the opportunity to use lower wattage fixtures or maybe less fixtures to achieve your 35 foot candle target. Just know that these surfaces can help you or they can hurt you, and they can also help inform your clients' decisions. If they want to be very aggressive with their energy savings, maybe they're trying to meet some kind of lead target, or they just want to use low power. This can be a real tool to help them. And you're thinking, well, who's doing these dark surfaces? But this is pretty typical. Saturated wall colors, dark floors, concrete, not uncommon to see. Here's a industrial application, and they just gone, sprayed everything is just white, bright white. It's much safer. Good visual acuity. Same thing here. But it can be even in humble areas. It's just a way to save energy and make it a safer environment. So how do you know the room reflectances? Well, one way you can do it is you take your trusty light meter. See if I can do this here. And you take your light level on the wall, take a reading, and you note it, write it down. And then you hold the meter out about 12 inches from the wall. Now, you probably don't want to do it near a window. So you want to find a space that's not getting, it has sort of typical lighting. And you take your light level reading there. And so now you've got two light level readings. And you just run a simple calculation with the light that's incident on the wall and the light that's reflected off the wall. And that gives you your percentage of absorption. And so you can use that number. And sometimes, you'll see color. Another way to do it, though, is I mentioned, going into the maintenance closet, you might find the paint that they're typically using. Maybe they're not planning to repaint as part of this lighting project. Although I always bring that up with them, especially if I see dark surfaces. Anyway, so you can see what color paint they're using. And as a case here, we've just got this cream colored paint, but I look at it and it's 63% reflective, which is, pretty good. But it could be better. Here's one that's similar. It's still very much of an off-white, 84% reflective. Down here, this little accent tan. Again, this could be the color they're planning to use. That's 50% reflective. So we see a real range here of reflectance. And anyway, that's just a way that you can find that out. Or you can talk to someone if they say, well, we're planning to paint. You don't just turn your hearing off and say, well, I don't care what color they paint. I'm just doing the lighting. You want to say, oh, really? What's the plan? And then you can find out, well, maybe they're planning to paint the walls dark blue, in which case it's time for that conversation. Exterior audits. What's the best time to do to look at exterior lighting? This is kind of a trick question. Would it be during the night or during the day? Obviously, it would probably be a little of both, because during the night, you can see what the light's doing in those spaces. But during the day, you can find out all kinds of other things like, hey, wow, these fixtures are on, this one's off. What does that mean? They've got problems with their controls, but maybe this one's also burned out. Another thing that you can see during the day, at night, you look at this fixture and all you see is just this bright thing. You can tell it's working, but you can't tell much else about it. During the day, you can say, oh my gosh, this lens is very discolored, very worn out. We need to replace the whole fixture, or at least the lens, to get better light levels. But you wouldn't be able to see that at night. Again, your trusty camera with the zoom lens, you can get up and see parts of the components, so you could tell the client, yeah, I know you want to replace all these lights, but you really ought to think about upgrading the structure because I see rust. In this case, it doesn't look structural, but you might see some structural issues that you could draw to your client's attention. And then some other more advanced analysis tools that you might want to use is a luminance meter. So your typical light meter that you're going to use tells you how much light is striking a surface. I put it up here and I can tell how much light is hitting that wall. But if I want to know accurately how much light is coming off of a surface, I need something different, and I would be, or how much light is coming off even of a light fixture. I would use this. With this meter, we get foot candles, and with the luminance meter, we get candelas per meter squared. Probably won't be using this a lot, frankly, and these meters tend to be very pricey. But it might be something that you'll want to think about. Data loggers, again, maybe you've got a warehouse application and the client is like, oh, we're going to save a ton of energy because we're just not in these aisles very much. You put a data logger in there and you find out, well, you're actually in there, 8 times a day in this aisle and 16 times a day in that aisle and 2 times a day in this other aisle. So you could do some consolidation and maybe get things a little more efficient, or at least calibrate your client's expectations. Spectrometer, we're seeing more interest in that with LED lights. People are curious as to about how much blue light they're putting out or how much red light. A flicker checker, we're seeing that again with LEDs, especially the cheaper ones. They tend to maybe have some flicker. Thermal imager, maybe they're getting premature failure on some of their lighting, and you can look at the light fixture and you can say, wow, you've got a real hot spot here. Maybe you've got problems with your ballast or your drivers or your power supplies, or maybe you can look and say, wow, you've got your air conditioning is blowing right on top of this fixture, and that's why it's not doing what you're hoping it would do. UV meters, ultraviolet. Sometimes people just put a GoPro on their helmet and they just walk around the space and turn that on from time to time as a way to capture what's going on. Okay, so we've talked about looking at the lights, and often a question that you'll be asked is, how much light do we need? If they don't have a good, they're like, you're here to help us. What should we be doing? I love this picture. It's from circa 1939, the captains of industry sitting around, and they've figured out these brand new lights. They get 200 foot candles of diffuse light. And this was quite a revelation back then, because up until that time, they were looking at mostly, dim incandescent lights that didn't give them a lot of light. And now they could make all the light they wanted. And guess it's interesting that the windows or blinds are shut. They didn't need daylight anymore because they had electric light, and this was a big deal. So we look at how much light is recommended. Here's the IES handbook from 1972, the 5th edition. And back then, the recommended light levels for, say, a general office application, reading in poor types of computer printouts or things that were hard to see, you need 150 foot candles. If it was better, reading surface, maybe only 70 foot candles. But this was the range they would have for, say, an office application back in 1972. We go to a more current one. This is the 10th edition from 2012. This is the most current, but this explains the trend here. So now we have offices from the IS handbook. We have offices, reading and writing. We go to high contrast of black ballpoint pen. We get a number here, 300. Wow, wait, 300, that seems like a big number. Well, if we go here we look, these are foot candles, but what we currently use now is lux. And so you're thinking, oh, wait, foot candles, lux, that's going to be really hard to keep track of. The good news is 300 lux is about 30 foot candles. So it's about 10 to 1. And here we have for blue ink or lower contrast 40, 400 lux or 40 foot candles. So we went from 150 or maybe even as low as 70 foot candles down to 30 foot candles is what's currently recommended for these office applications. So when they say, oh, well, we have this is based on IS recommendations, say, well, what year was this from? And it might be from the 70s when they got those standards. Time to modernize. So how much light do we need? The other question that comes on shortly after that is how much light will I get? And that's going to be a function of the types of luminaires, the quantity of luminaires, the wattage of luminaires that you use. And there's a lot of variation there, even with just this one high bay type fixture. This would be used in a industrial application, but it could be used in a school gymnasium or even food courts. All kinds of places might use this type of fixture, big volume spaces, airports, concourse possibly. And there's all these different variations on this fixture. So let's take a quick look here. So we can buy with this fixture, the JCBL, we can get either 9,000 lumens all the way up to 30,000 lumens. Lumens is just a quantity of light. So we can, and then we can get different reflector types, diffuse aluminum, we can get clear acrylic, polycarbonate, etc., frosted, different lenses, different voltages. It's all one driver, they all come dimmable, different colors, we'll talk about that in a second, and different color renderings, and we'll talk about that. And that'll have an implication on how much light you get for the same fixture. And so let's just drill in a little bit on that. We're going to just, in the interest of time, go through a little bit on color properties of light. So here's two light sources that would nominally be considered white light architectural light sources. So we can see there's a pretty big difference between them. This is a little extreme. This one down here is low pressure sodium. This one up here is a modern high metal halide light source. Pretty big difference. If you look at these cars, these are the same little cars so here we have the red car, and here you can hardly tell what color it is. This is the blue car, same thing. You can't tell one from the other, and the tree looks dead. So what's going on? Well, one thing we noticed about those other boxes was the color. One was yellow and one was sort of white. We call that color temperature, correlated color temperature, CCT. We use the Kelvin scale when we talk about light color. So we might say 1400 kelvins for a given light source. It's not like Fahrenheit or centigrade, it's a scientific scale. And every light source, so a candlelight would be around 1500 kelvins. We go up to incandescent light, around 2700 to 3000. Daylight actually has a number, although it changes. Sunlight, same thing. And then fluorescent lights have a whole range of possible colors. The good news is, I suppose, is that LEDs can be almost any color temperature. You just have to pick one. The other thing is color rendering. So that other box that we showed is a fairly stark example. But if we look at these two boxes here, it's a little more subtle, but you can see the complexions on these faces. Here the people look healthy. Here they just look a little jaundiced. And it's kind of a subliminal thing, but when you walk into a space and everybody looks like they're not well, we just don't get good feelings about that space. Plus, if you're selling, if you're involved in retail or any kind of hospitality, colors look flat. It's just not good. So The good news is almost all LEDs come in good to excellent range. So it's just a case of picking which one you want. Usually the higher the better when it comes to color rendering. Not going to spend too much time on this, but we can see high pressure sodium, an obsolete light, mercury vapor, even more obsolete, but they're used very commonly for exterior. And here we have a modern white light source. All these colors pop out, so there's safety issues involved with that. So let's go back to our little chart here. So if we were to pick a 30,000 lumen nominal fixture, 4,000 kelvins, 70 CRI, we're going to get about 28,000 lumens. We could actually even get a little higher than that, 29,000. So pretty much as said. But if we were to say, and this might be fine for like a warehouse or industrial application, perhaps, parking, any kinds of thing like that, would be more than adequate. But if we were, say, doing a food court or maybe a big box retail, we want something maybe a little warmer, 3,000 kelvins and maybe higher color rendering, 90 CRI. Now we're at 19,000 lumens, almost let's say 20,000, 19,700. So that's a fairly significant difference in light level. And you just need to know that going in. So here we are with the 4,070 CRI, it's 125 lumens per watt, but the 3,000 Kelvin 90 CRI is 80 lumens per watt. Again, this just may be the price you have to pay to get the kind of lighting that's warranted for that given space. But you just don't want any surprises there when you end up getting less light than you anticipated. You know, someone said, isn't lighting getting easier? Now it's just LED. So that one fixture that we looked at comes in all these different, if you were modeling that fixture, all these different little photometric combinations. So you're not gonna, fortunately you don't have to model all of them, but you might have to model quite a few. So here's a little quiz. We'll just walk through it in the interest of time. But here's, you know, an office interior. It's all white surfaces. You don't have to usually go to this extreme, but what are the benefits of lighter surfaces? The potential to save energy. By the way, I should say it's only the potential, because if you don't actually use less light or less wattage, because you have lighter surfaces, you're not going to save any energy. Improve visual comfort, lower contrast ratios, potential for higher light levels if you needed them for a lower wattage. And no, this isn't just interior design. It's really something that you need to be aware of as part of the lighting team. Okay, we're just going to blast through these retrofit applications. So common retrofit applications are going to be fluorescent troughers, or maybe I should say anything that uses linear fluorescent lamps. Recessed fixtures are getting retrofitted a lot. Exterior fixtures getting replaced or retrofitted, high bay industrial, and even interior surface mounted fixtures, decorative. So, you know, there's a lot of product out there that looks like a fluorescent tube that uses LEDs. We in the industry call them TLEDs. You might see that in some literature. And there's all different kinds out there. Some of them have no lens, or they have a lens that's clear. So you're gonna get lots of sparkle, which may or may not be what you're interested in, or you might get patterning that's different than you had with fluorescent. You know, the thing to keep in mind, when these are working perfectly, they look just like the fluorescent tubes that you took out, except they ideally use less energy and maybe give you better longevity. Sometimes they have wide end caps. Sometimes they have metal on them, although we're seeing less of that now. Sometimes they're just made of glass. They're not all plastic. Plastic has its advantages, but plastic's more expensive. There's a whole industry out there set up to make 4-foot glass tubes, and they're trying to get some more use out of that equipment before everything just goes LED. But one of the things about a fluorescent tube is if here's a cross section of our tube, we get uniform light pretty much out around that entire thing. It's an omnidirectional light source. Whereas these TLEDs generally only have half of them radiant or translucent. And usually it doesn't come out, so here we've got one that was measured at 105 degree beam, which is, we'll see, is maybe okay. And it's a 180-degree aperture. Sometimes when you're looking at the promotional material for these, they'll say 240-degree aperture. Well, that's great, but I still only get 160 degrees of light, not even 180 of usable light. So you want to be aware of that. How, like I say, if we're just coming out of a directional fixture, with this fluorescent, we basically just want to send that light down out of the fixture into the space, so that directionality might possibly be an advantage. But if I have a linear pendant, here's our cross section, there's our light source. Here's the light source again in its photometric diagram. We want some light to come up, and we want some light to go down. And if I have one that only is one-sided, that's a problem. So of the types of TLEDs, there's basically 3 sorts of wiring or non-wiring options that you have. One says no rewiring. It's ballast compatible, uses existing ballast, and that's called UL type A. The other type does require to rewire. You have to disconnect the ballast and rewire the sockets. And basically then the sockets are getting line voltage, and that's UL type B. And then there's a sort of variation on that where you're rewiring, but the driver is remote, and the sockets are not even energized, and that would be UL type C. And so then you have to ask, when does a tube become a kit? And we'll talk about that as we go, because that's an important distinction for some entities. So let's go look at UL type A, where we're the ballast compatible. And we'll just look at, you always have to read the fine print is what I'm going to encourage you to do. So it says compatible is 90% of electronic ballasts. Okay, so 10% right up there, we know 10% are going to be a problem potentially, including instant start, program start, rapid start, dimmable fluorescent, etc. We look down at these notes here, and it says, due to numerous ballast designs and topologies, this lamp should be tested on existing ballasts before mass quantities are installed. Well, that makes sense. You get a case of them, try them out. But remember that one room that we looked at where it had all different kinds of ballasts just in that one room. So you need to be a little aware that if you're looking at a whole campus or a whole high-rise building, you're going to have some variation. This is not intended with use with older dedicated voltage instant start ballasts. Well, instant start ballasts are by far the most common kind you're going to see out there in the built environment. And I'm just going to say, if you're doing a retrofit, usually it's on older equipment. You're not usually retrofitting new equipment. So intended for use with older instant start ballast. These ballasts have electronic components that degrade over time and may become unstable. So, okay. They're saying that they're ballast compatible, but they're not compatible with probably what you have. Here's another one where you rewire them. So you're thinking, okay, yeah, this ballast thing looks like a problem, so we're just going to do a rewire, so we're eliminating the concerns we might have about ballast compatibility. So most include an integrated driver. So these will have their driver built right into them, and they're powered directly by the 120 volts, sometimes even 277 if that's what you have. Improper wiring can result in product failure, so you need to be careful because they get wired differently. Different products get wired different ways. And then further, each lamp type may require either shunted or unshunted lamp holders. Wait, what does that mean? What that means is the sockets, the lamp holders, sometimes they're called tombstones in the industry. There's two types out there. They look pretty much the same, but they're different. So here's a rapid start, non-shunted. Here's an instant start, shunted. I mean, we just said that instant starts are by far the most common you'll see. Do not use this retrofit kit in luminaires employing shunted bipen lamp holders. Okay, so that would be instant start. Don't use it in those. Shunted lamp holders are found only in instant start balance. So, you know, basically what this is saying is you're going to be replacing the sockets. You're going to be bypassing the ballast and replacing the sockets. It's just a lot more work. So there's products out there where you sell you two pieces of equipment. They sell you the tubes and a driver that would be brand new. So you're not dealing with old ballasts out there. You have a brand new driver that you put in and usually included. So you know there's compatibility. You're buying it all one manufacturer. Another similar product here. So that's one way to get around some of that. But again, you know, that's more work than just unscrewing the tube and putting in another tube, which is sort of the promise of a lot of those TLEDs. Here's one that's a little different, where you have your remote driver. It doesn't come in through the pins. It comes into the back of the tube. So you're just energizing directly there, and the pins, the sockets then just become lamp holders. There's no power going to them. They're just mechanically holding that tube in place. That's one way to get around it, potentially, assuming that the sockets are in good shape and are all worn out from vibration or heat. Again, that's where you want to inspect the fixtures. And here's your basic kit. It looks a little bit like the one we just saw, but in this case, we've got our remote driver energizing the tubes, no pins at all. These just don't even touch the sockets, and they are stuck up with magnets to the steel housing. And just know that there are some requirements by some utilities that they'll only incent on a kit. They want to incent on tubes, and sometimes the definition is if the product is touching the sockets, it's a tube. If it's not touching the sockets, it's a kit. So you just want to look at the fine print whoever you're dealing with, and make sure that you're going to be in good shape. No surprises. So here's another type of kit. There's all different kinds out there. Here's one where it's just all these different parts and pieces, you know, sort of assembling this thing in place up on a ladder. In theory, a lot of it snaps together, and there's just some simple tech screws here and there, but it's a lot of work, a lot of pieces to keep track of. And then you've got a nice new lens. One of the things about, say, let's just go back to this one and all the other ones we looked at, is you basically get the same fixture. Again, these are just looking, so if you didn't like the fixtures you had, and you didn't like the way they were distributing the light, you haven't changed much. Here you've at least got what looks like a brand new fixture, and you've just used the housing. The only thing I would mention, some of these kits can be fairly expensive, and some of them you buy out of the box. You just hook up you take out the old lens, remove all the guts. You just leave the housing in place and the power whip coming down. Hook it up, put it up all in one piece. But they cost almost as much as a new fixture. The advantage would be you're not opening up that plenum. Maybe there's lots of dirt up there, or maybe asbestos, or just things you don't want to deal with in that regard. So this is in some ways easier than putting a whole new fixture. That said, if you're doing if this is your existing and you're going to remodel a full antenna improvement, you got new furniture, new carpeting, maybe even new paint, it's probably time to put in some new lighting. as well. Because what looked okay before probably won't look okay with all that new stuff. All right, so here's another example of surface mount decorative fixtures. And there's two things we're going to touch on as we look at this. One is luminaire efficiency, and the other is replacing compact fluorescents with LEDs. And so here we've got this particular decorative fixture has four 1800 lumen compact fluorescents, so we have a total of 7200 lumens. Here's our LED. It's a 83 watts. Here's our LED. It's 24 watts, and it's got 2500 lumens, let's say. And here's another one, 22 watts, about 2000 lumens. Well, neither of these look like they're going to come close to replacing this in terms of light output. There's a lot of savings, but not really getting us what we want. But if we look here at the photometric file for this fixture, the existing one, we can see that it's only 37% efficient, say 40% efficient. That means 60% of the light never makes it out of that fixture. So I can take my 7200 lumens and take out 60% of that. Now I'm at 2600 lumens. And those other fixtures start looking more like the actual light we're going to get. But we have to read some of the fine print. So on the fixture, the LED fixture A, it said source lumens, and they were the 2500. So we don't really know what the luminaire efficiency is of this fixture, but we can guess it's probably maybe 50%, or maybe it's more than that. Maybe it's because it's different materials, but there's going to be some losses due to the luminaire. When we just look at the fixture B, it says delivered lumens 1800, almost say 2000. So even though it looks similar, this one's source lumens, this one's delivered lumens. This means they've actually put the fixture up, run it through, done a photometric check on it, and seen how much light we actually get out of the fixture. And you can find that, again, light output in lumens for the luminaire. It'll tell you how many lumens you're going to get. If you make any changes, maybe you change that from a white lens to an amber lens for whatever reason, you got to redo the photometrics. It'll be this lumen output will be a different number. You also want to look at how the light is being distributed from your light sources for given fixtures, particularly recessed cans. Here we have a directional lamp, and here we have an omnidirectional lamp. This one's maybe 95 lumens per watt. This one's 75 lumens per watt. So we're thinking, well, this one we're going to get more light out of, but it just depends where we want that light. With a directional lamp, it's going to deliver light in a pattern. And we're looking at, a lot of times we'll see out of either fixture types or lamp types, we'll see a thing called the beam angle. That's where the light level drops to 50% from center beam. Once it gets down to 50%, that's the beam angle. There's still going to be other light, but it's going to be less as you go out, down to 10%. So lots of recessed cans. Here's this sort of cross section of a recessed can. We take an omnidirectional lamp, and it could be metal halide, or it could be incandescent or compact fluorescent, 65 lumens per watt, let's say. We put it inside of a fixture that's about 50% efficient. So now we're really looking at about 35 lumens per watt for the fixture. And that's just a distinction you need to be aware of. Here's a case with a recessed can. I was doing a site visit. We've got compact fluorescent lamps in here. Stuck my head up in the plenum, up above the ceiling. This one loses 40% of its light due to inefficiencies, or just luminaire losses. So here I can see quite well up there. I don't have a flashlight going. It's just all the light that's escaping from all the different fixtures going down this corridor. That's just light that's not making it down into the work area. So that's how we can take a compact fluorescent, replace it with maybe 26 watt, put in a 13 watt LED and get as much, if not more light, because these tend to be directional. But you do need to be sure they're compatible. Here's one where it says simply plug a replacement lamp into the existing ballast. So here's our LED directional we just plug it right in, right? What could simpler? Well, I have to make sure it's compatible. Well, I looked at the ballast that we had a fixture. It was advanced smart mate. So here we go, advanced, and it's compatible with our 120 volt single lamp, but it didn't work. Don't know why. Let's see. So we read the fine print. While each ballast type has undergone testing, some have undergone revisions that may change the operating parameters. So performing an on-site test is recommended before you put a bunch of them. It's supposed to work, didn't work. Here's another one. It's like Tom Waite said, the large print giveth and the small print taketh away. So here we've got compatible with most fluorescent ballasts. Well, that's cool. But then if I read the fine print, says, for maintenance and energy savings reasons, this company recommends bypassing all ballasts for permanent installation. I'm pretty sure that if you go through the trouble of retrofitting these fixtures with these, you're not doing it for just a couple of weeks at a time. You're just, set it and forget it. Here's a retrofit kit. So now we're getting rid of all the ballasts and socket issues, and we're just putting in this kit. And so we know it's going to work. It's got all the electronics built into it, but it is a different look. Here we have a recess product that's up above the ceiling. Here, this one has a lens, could be acceptable, might not be. Might check a few before you buy, 10 cases of them to put in your 12-story building. Here's ones that look more like the recessed fixture that you took out. So we've got our LED source tucked way up in there. We've got nice heat sinking. It's truly recessed. These cost about as much as a new fixture, but the good news is you can just take out, you're not changing, you can do all the work from below. So and it gives you better optics. Moving on to high intensity discharge. Yes.
Really quick, kind of along those same lines. Just wondering what your opinion is about the integrated LED fixtures versus standard bulb fixtures for commercial settings, kind of like this person replaced the fixtures in their house with integrated LED fixtures, but now realizes if something goes wrong, they have to get a whole new fixture instead of a bulb. So is it not a practical solution for commercial? I mean, it's annoying for residential.
Yeah, it's a tricky thing. So the manufacturers are often, they'll make a replaceable driver. You need to be able to, so that's just code. You have to be able to get in and get that driver out. So if the driver fails, you can replace that. And often the optic can be replaced. So on all of that, in theory, even with a little 4-inch aperture, you need to be able to get your hand up in there and get all those components out of there. In commercial settings, they're usually bigger apertures, so it's not as much of a problem, or you have a different type of ceiling condition, so you can access the fixture easier. Those components are, in theory, replaceable, but that's something you want to look for in a fixture type. One thing I encourage people to do, especially in a big commercial project, is buy some extras. So even if they're under warranty, you've got to, if you're putting in 400 fixtures in a large building, you're going to get some that are going to fail prematurely, and they'll still be under warranty. So you can either be battling with the manufacturer or whoever, the contractor, to find out who's responsible, or you can have a couple in your closet. You put those in. Now you can be talking. There's not so much urgency to get it replaced right away. So, and that's also, if over time none of them have problems, but you reach the point where, 10 years later, 15 years later, they're starting to fail. You've got a few spare parts in the closet that you can use to replace some of those ones that fail a little earlier before you have to just generally replace them all. So yeah, it's going to be a bit of an issue though.
And then I
Yeah,
think you're going to go over this in the LLC section, but they were wondering thoughts on integrated, wireless integrated smart tech controllers versus standard lighting controls. You're going to go over that in LLC section?
a little bit. Yeah,
Okay.
yeah, we'll touch on that. You know, and I guess I would say it depends on whether you're talking residentially or on a commercial setting. So maybe the person who's asking the question could let you know. And I'm just going to blast through this here in the interest of time. So, you know, metal halide or high intensity discharge fixtures, there's not a lot of them out there, but they tend to have a lot of energy. You know, you're looking at 400 watt, even 1,000 watt fixtures. And so if you can replace those or retrofit those, you're capturing a high energy load. But one thing you need to be aware of, most of what makes these high intensity discharge fixtures work so well, and you can put them up on a 40-foot pole and get light going out, 2 mounting heights in every direction, or or maybe you just want to send light in one direction, forward if you're lighting a roadway. You don't want light spilling all over the place. Is the optics, and they're designed around a point source, that tiny little thing that's getting bright as the sun. You can control very easily. And with LEDs, they work on a slightly different principle. Usually you're seeing an array of LEDs. And so here I've got 760 lumens for 7 watts. If I need more than that, I need a bigger array of LEDs. And so that's nothing like a point source. It's maybe okay for some applications. Here's an omnidirectional, here's a directional. So maybe if I'm doing a shoebox type fixture, I just want light to come down. I'm sort of bypassing this whole optical assembly, just pushing that light down. Here's another case where I'm pushing it down, directional. And that can be fine if you've got a metal reflector, but lots of times you have a translucent reflector, and that before, and this is what they have now. For many applications, that's fine, but we found in some retail applications, they don't like to see that. They want the sparkle all the way. And so you don't want to, work all weekend putting up 400 of these things, retrofitting, to find out that then you have to go and redo it again or take them all down because the client didn't know that's what it was going to look like. Here's another case. You can tell how old this picture is. This is the bus tunnel in downtown Seattle. Now it's the transit tunnel, the light rail. But these fixtures got retrofitted. These ones got retrofitted too, but they couldn't get anything for that upper part. So now these are just dim. And you can see it's nice bright tiles here. The tiles we don't get the vertical surfaces lit with these. Could be a deal breaker in some applications. Quickly, here's a project that we did, big industrial space. You can see there's a person standing there, 28-foot racking. We had a lot to fix. These were old mercury vapor fixtures that they wanted to retrofit. And they were just bringing us in to say, hey, what do you of this retrofit? So what we had to do was first model it with the old fixtures. So we sort of guesstimated, we knew they had 400 watt. And they were new. This is how much light they would have had, about 30-foot candles in this big space, and about 2 lumens per watt for 64 fixtures. So with the retrofit, it was a screw-in retrofit here, wattage down at 160 watts. We got 35-foot candles, more light, 0.7 watts per square foot. Lighting power density, 64 fixtures. So hey, I mean, we're cut the power in half. Let's pop the champagne corks. But what would happen if we used an actual fixture? So here's a real high bay fixture. Well, they were 277 watts. We get a whopping 80-foot candles, 1 watt per square foot, 64 fixtures. This is way more light than we need. and the light level, or the power density has gone up a little from 0.7 to 1. But if we look at a little more closely at these numbers, so that's with 80 brand new fixtures. But what if we only used half of those fixtures? Because there were a lot of fixtures in that space. Now we're at 42-foot candles, 0.5 watts per square foot, and we've only purchased half the number of fixtures. So even though there were more expensive fixtures, they were $500 fixtures. You know, these retrofits that they were using back then were $300 a piece, so that was real money. And by the way, they had to send somebody up on a lift to rewire those fixtures. So they all already had to go up there to rewire the fixture. So just from a Luminaire standpoint, it was actually cheaper. They saved more energy. So sometimes it doesn't hurt to look a little more closely at these projects. So here we go. Before doing an LED lamp only retrofit, always check to see which of the following: that they're in good shape, that the lamp is compatible with the electronics in the fixtures and the existing controls, that the optics are appropriate, that the utility is agreeable. You want to make sure that it's something they're going to want to incent on. Is it a Energy Star fixture, or is it on some other list? Oh, and by the way, that the customer has enough money. No, that's not really, that's a little joke. But still, you want to check all these things to make sure that you're retrofitting the proper fixture. All right, we're going to blast on to, I know you've all been waiting for this, Luminaire Level Lighting Control and Network Lighting Control portion of the presentation. And I'm pretty sure we can do this. So why use lighting controls at all? Well, to save energy costs and to save on maintenance cost. You don't want these lights burning all night long because it runs the meter and it runs the clock on the lamps burning out soon. So how do you control them? Well, you can turn them on and off. It's kind of a blunt instrument, right? I mean, it shouldn't be necessarily just all or nothing. So we could put occupancy sensors on them. Well, that's pretty good. So now we know when space is empty, the lights will be off. But what about just one guy's in there? I mean, I don't want to belittle this guy's importance, but all the lights are on, just one person in this big room. The other way, you've got all the lights off pretty much, and now we've just got one person, a lonely person in this little pool of light. That's not necessarily what we want either. So let's see if we can get to something that we're going to like. Well, lighting controls, our demands for lighting have become a little bit more nuanced, a little more sophisticated, a little broader. We're used to lights changing intensity, right? We're used to dimmers. We're used to lights changing based on occupancy. We're used to lights changing in response to changing daylighting conditions. And we're also used to lights changing based on our preference. And maybe the tasks change, so the lighting would change. So all these things we're either expecting or we're accustomed to. And the ways that we do that are with switches. Sometimes we have switches, but usually we're using like a time clock. We're using sensors, daylight sensors, motion sensors of different kinds, or even just manual dimming. One of the problems with historically with sensors is setting them up. We have all these little sort of dip switches that we're playing with, or little dials that you need tiny screwdrivers for, and it's just been a mess to set up the parameters by which we want the lighting to change. So wouldn't it be not just one button? So here's a product that's just one button. It seems like, wow, that's pretty simple. But sometimes you can go too simple, right? So we have this one button and we have to press it. Say we want to change the occupancy delay to 15 minutes. We have to press the button. First we have to get it into programming mode. Then we have to press the button 7 times. Got to count 1, 2, 3. It's a 7. and then it'll flash back to you, and you have to count the number of flashes back to tell you that yes, you hit 7 and not 10 or 8 or 6. And so then you hit enter, and then maybe you want to change the set point for the photocell. You want it to be 32 foot candles. You got to press it 9 times, and you got to go through the whole process. It's kind of a mess. You know, you're trying to go through all these different menus and while you're remembering which function you're setting. Meanwhile, you got the painters going through. You got punch list. Some guy's trying to lay carpet. You're going from restroom to restroom, setting these up, and then now you're trying to set up classrooms, and it's kind of, you know, it's fraught. So now we have fixtures that sort of are smart. They're self-programming, and that's pretty cool. And I will say these are pretty cool when they work. You know, you put the lighting in, you take your controller here, you press the big button, and it'll go through sequences and it'll set itself up, and I've seen it work. It works pretty good. Different companies make variations on this, and but if there's a hiccup where you have to change it, it's kind of a mess. So, you know, not perfect. Another thing, you know, this one has this sort of wand that just has a couple buttons. You're not sure what they necessarily do. We're used to these sort of GUIs, graphical user interfaces, either on your phone or a tablet. There's issues with compatibility there, but at least, you know, it's more intuitive. So there's progress as we go. One reason that we do controls is because they're required with energy codes. So for instance, daylighting responsive controls are mandatory in most spaces nowadays. So how might that look? I mean, we're used to seeing it. Here's a floor plate with a perimeter, lots of windows here. So all these daylight zones. But guess what? Now we have to have primary and secondary daylight zones. Okay, well, that's twice as many things to wonder about. Layer onto that, we've got occupancy controls. They're also mandatory in lots of spaces. We're used to seeing occupancy in, you know, closed offices, restrooms, conference rooms, those kinds of places. We're used to that. But now, pretty much every place needs occupancy of some kind. Layer on top of that egress pathway lighting that you either want to put in or are required to put in, and the whole thing gets very complicated very fast between the daylighting, the egress, the occupancy everywhere. You know, what can some of that stuff look like? So when we've got a room that's empty and the lights are on, we know that's not good. You look inside that gymnasium, you see the lights on. Well, we can fix that. Room's empty, the lights are off, and there's lots of daylight. That looks pretty good. What happens when the room is occupied? Does someone walk in there and all the lights come on even though there's plenty of daylight? What we would ideally like to see is occupied space, lots of nice, sort of good daylight. The lights are off, and that's a success. So how do we get there? Well, we can do all these different controls that we talked about, the occupancy sensors, daylighting controls, those sorts of things, or we can use what's called Luminaire Level Lighting Controls. And what is that? Because if we do that, we basically bypass all of the kind of controls criteria in the energy code. Well, Luminaire Level Lighting Controls is a lighting system consisting of one or more luminaires with embedded lighting control logic, occupancy and ambient light sensors, wirelessly networked, and local override switching capability. Wow. Are they saying every fixture needs to have its own controls? That could never happen. Well, we're used to seeing that, you know, we've had photo controls on roadway lights. I don't know, maybe not everybody's a lighting nerd like me, but, you know, I see photocells on roadway lights all the time. And so that's a case where we have one fixture and one controller. We've also started putting them into warehouse lighting spaces. We've gotten rid of the metal halides that were almost impossible to control. And once we went to fluorescent tubes, high output fluorescent tubes, we could add a controller so that when spaces were empty, the lights would go off. But you get into like a warehouse, the lighting, there aren't as many lights. But to get into an office space, interior spaces, and there's just a lot more lights, higher fixture density per square foot. So putting a little controller on every one of those is a lot, and historically didn't make any sense. But now we have a convergence of technologies and timing. So the technologies are that we've got miniaturized control devices. They're littler. They can be built right into the housings without too much trouble. We've got a much more controllable light source. Even though fluorescent has been controllable, it's just not as controllable as LEDs. They're a lot easier to control. The thing is, you might have noticed when I read the definition of a Luminaire Level Lighting Control system, it's networked. So trying to network all that stuff together, in the early days, in the 80s and 90s, even the early 2000s, bandwidth just wasn't there. Now we have much higher bandwidth systems. And the other thing that's pushing us over the edge, if you will, is more demanding energy codes. So we're often required to do it. So all these things have come together to help that out. So what are the advantages of Luminaire Level Lighting Controls? Primarily, beyond the controls that we just mentioned, you can also get things with temperature control, you can security, little cameras in there, you can have CO2 sensors, you get higher granularity. There's no rewiring needed necessarily. You just take out your old fixture that already had power, put in the new fixture, it's already got the controls, and it's got wireless controls talking to all the other fixtures. So their ability to rezone if the area changes, use changes is pretty simple. You just reprogram. And lighting's a real handy place to put these controls because lighting's everywhere that people are for the most part. It's usually up high so it can kind of see into the space for occupancy reasons. And as I mentioned, it offers power, which is usually something that the controls need on some level. So how might this look in a real application? Here's a big floor plate of an office plan, and we can see there's our elevator lobby here. So what might this look like? So let's say it's nighttime, and we've got maybe for whatever reason we decide we just want to have some lights on all the time at 10%. So there's just a little glow on an egress corridor in the lobby and the main aisleways. And now we get somebody who comes into the office early. It's still dark outside. They're the first person in the office. So you get off the elevator lobby and all the lights go to 30%. Everything just kind of goes up a little bit. But in this elevator lobby, it's up at 90%. Along with this, once they step into this corridor, this goes up to 90%. Everything else is still down at 30%. And now they go to their workstation. This is up at 90%, and they're just going to work away in that little area. Now it's a little bit later in the day. Someone else comes in. So it's still, let's say it's summertime and it's 7 in the morning, or maybe it's 7:30, and we've got another person, one more person comes in. But by this time there's plenty of daylight. So all these lights are either off or very low, and all these lights, now this is our 30% zone. But our other worker, he's still there. He's still working weights up at 90%. This area is at 90% because someone came into this interior space, and now they go to their workstation. So we've got 90%, 90%, 30%, and off. And you can do this because all those fixtures out there have their own little autonomous daylight sensors. And now, maybe it's slightly occupied. It's summertime, a lot of people are off on vacation, so we've got somebody working here, someone working there, a couple people here. Maybe the conference room is occupied. They've got the blinds shut though, so the lights are on. Just different ways. You can see how there's just lots of savings potential here with this idea Luminaire Level Lighting Control. I love this picture because it shows it doesn't have to be just trough or recess style fixtures. Here's some pendants that were put in. And if we look closely, we can see someone's working here, their light's on. We've got someone is vacant here. They're not working that day or whatever, they've stepped out to lunch. Their light's off. There's someone working over here. Their light's on a little bit, but not as much because they're right by the window. Whereas, fixture here is interior space, and you can really see it's on at 100%. They're not getting much daylight, and they're there. They're occupied. So that's a pretty good story. Whoops, that's the wrong way. A little quiz. So what's the most effective retrofit luminaire? It's energy efficient, has appropriate color qualities, puts light where it's needed, has low operating costs, and is controllable. So we're just going to blast through that. And I think that's the end of our presentation. So I think we came in just on time. Katie, hopefully you're still awake.
Yes, I liked your I see dead people reference earlier. I caught that.
Okay, great.
Yeah.
Yeah. I see lighting controls.
Yes.
Yeah, so thank you very much. If there are any questions, feel free to put them in the chat. Maybe Katie's got one or two, or you can certainly email me. I think my contact information is at the end here.
Yeah, we don't have any questions in the chat right now, but let's leave cute little Olive and go to this slide just to remind everybody that in July, City Light increased some of their incentives. And in September, we added 2 new program offerings, the Energy Project Manager and Project Development Incentive. If you missed our November, I think it was the 16th webinar, go check that out on our website or email SCL Energy Advisor and they'll give you some information. Oh, we're getting a whole bunch of questions now. So let's just leave that slide up for a minute while we ask these questions. Nikolay asked, can you elaborate on the implementation cost of LLC versus standalone combined sensors per zone? That's a good question.
Yeah, well, I mean, it varies, obviously. And as these types of fixtures become more popular and more widely used, the price is coming down, as we've seen that recently. So as I mentioned earlier, especially in a retrofit application, you're just taking out an existing fixture and putting in a fixture in the same spot, and it's ready to go. Whereas if you were going to then overlay, if you were just putting in a new fixture that didn't have LLC controls, you're having to run maybe some wiring or adding some gateways here and there to receive the signals from the various controls. You're having to zone in a way that you maybe isn't quite as granular as you would like, but possibly just as acceptable. But you go back to something like this, you couldn't really do this kind of granularity with standalone controls. So there's costs associated with that, long-term costs, but also setting it up. I don't know if that answers your question. The fixtures themselves probably cost a little bit more. One thing I should say, though, is the utilities are very eager to have you use them. And so the incentives are higher if you use LLC product. I don't know, let's see, let's go to that slide that we had up.
Yeah, lighting and lighting controls have both increased through the end of at least through the end of the year.
Yeah, and I know they're also giving a little extra boost to using LLC type fixtures over and beyond just controls. So you can put in LED fixtures, get an incentive for that, add controls, get an incentive for that. But if you use LLC, I think you get an even higher incentive.
And those links work when you get when you get the PowerPoints off our website later, you can't obviously click them right now, but yeah, so you can see details on that.
Yep. Another question?
I lied. It was 2 thank yous. It wasn't
Oh,
questions.
yeah. Well,
But I had a question. The
okay.
the lights that we have now in SMT here, they
Mhm.
have the individual controls on them, right?
They do, yeah. So I can be at, I can walk into an area that's unoccupied. You know, we're in hybrid, so there's areas during the workday where there might be a group of desks, 3 or 4 desks that are unoccupied, where people are away at meetings and maybe just people are working from home. And they can be right by the perimeter zone, so they'll be off. But if I walk into that area, the lights will come on, but they won't come on to full brightness because they're by the window. So yeah, it's working there. You bet. And that's the
Yeah.
model they're going to use for the entire building, as I understand it.
Oh, cool. Yeah, it's
Hmm.
fun on a Friday. There are very few people here on Fridays in the office. By the time I leave, my bank is the only bank that's
There
on.
you go. Yeah, thanks for that little nudge there, Katie. Yeah, that's a great point. So yeah, we're trying to walk the talk, if you will, and yeah, there's some big advantages, I think, just in terms of simplicity and reconfiguration that you get. Um,
Yep. And thanks, Sean pushed this through, right? Really, Sean Dara,
yeah.
who attendees may remember from the lab too.
Hmm.
Um, oh, Benjamin asked, will the slide deck be available after the call? Yep, I will put the recording up. I will try to get it in within a week. Sometimes it's a couple days longer, but the slide deck and the recording of this video will be up on our website. There's Eric's contact info. Is that the right number, Eric, now? Or is this the
Yeah,
old slide deck?
that'll work. Yeah,
Okay,
that'll be.
and email. Email works 100% of the time. So,
Yeah. And I
um,
apologize for the rough start. We had a little bit of technical difficulties, and so yeah, that's
yep. We try to get ready for you guys about a half hour ahead of time, and it took 35 minutes this day.
yeah.
Oh, Nancy, right before we leave, Nancy said example of an LLC. Manufacture, that was a question. Manufacturers don't necessarily refer to their products this way. That's true. That's kind of a more local term, the LLC.
Well, it's sort of national, but yeah, they'll often say integrated controls. You want to look for maybe that language. And sometimes it'll be an option, right? So you'll look at the fixture and then you look at the options. You can get dimmable or non-dimmable, or you can get different controls, and then they can be baked right into them. Uh, so look at those as when you're specifying as options. But plenty of manufacturers,
And
that's how they make them. Go ahead.
does the DLC list have LLLC products called out, or I know City Light has it in their incentives.
Yeah, I'm pretty sure they do have a separate listing, but most of the major manufacturers are going to have. Well, one thing I would say, it's a little harder when you're looking at like a linear pendant. Uh, it's trickier there. It's almost impossible with a recessed can. So if you're doing a mix where you've got troffer style fixtures and then some recessed fixtures, you're not going to probably get LLC on a recessed can. I mean, it's not impossible, but usually it's just not workable. So you're often putting that controller separately, but it'll be part of the same control ecosystem, if you will. It just will be separate from the fixture.
Yeah, I can see that on the little recessed cans here. They don't have sensors, but they go off when the troffers next to them go off.
Correct.
Yeah.
Yeah.
All right, we're at noon. Bunch of thank yous, but no more questions. So we can all go to lunch now.
Yay. Well, thank you very much.
Thank you, everyone. Have a good afternoon. Go Hawks. Maybe we'll see you next week next week for the financing webinar.